Now that you had collected a lot of data through all the previous maybe 10 videos or more about the reliability-centered maintenance, about the information sheet, and we had collected a lot of data in the information sheet, this data is arranged by the failure, function failure, failure effect, failure modes, and so on. And we had explained all this with detailed examples and real life example and all of this. Now we had a lot of data with us. We need to brainstorm, to put some ideas and to arrange this data so we can go through it. That straightforward approach. We start by the reference of what we had collected from the data. We see the consequences and then we draw the tasks. From today, we will start working with the decision worksheet of the reliability-centered maintenance. Okay, this decision worksheet simply draws a roadmap to how reliability-centered maintenance works, or what we are going to achieve with the reliability-centered maintenance work. That's what we are going to see in this video. In this video about the decision manifesto, we had seen these two worksheets before. The information worksheet, which is the one on the bottom, we had been through the function failure, failure mode, failure effects, and say type of data, and so on. Then we need to draw some conclusions, or at least before drawing the conclusions or putting the tasks, we need to conclude, to make some conclusions out of this data before putting the task. Why? Because our north start from working with these two sheets and reliability-centered maintenance is to reach to the tasks that are really needed for maintenance, that are really feasible for maintenance, that are really added value to the maintenance. So as a result of the reliability-centered maintenance, you should understand that you may add tasks, you may perform tasks differently, or you may drop some tasks, you will transfer them to what is called no maintenance, or no scheduled maintenance is required, or no scheduled maintenance, whatever you like to call it, but simply it's let it fail because there is no feasible action or feasible task that can be done for the failure to reduce the effects of the failure. So you can refer to all the previous videos to understand what we had reached. Now as we had collected the system, subsystem, and we had divided our the area we are studying, or the complete plant, into our production lines, into systems and subsystems, and then we had made the functions and the primary and secondary functions. Now we had understood the function failure, which is maybe complete failure or partial failure, either for the primary or the secondary functions, the failure modes, and the failure, which are the failure causes, and the failure effect, which is an essay type, includes everything about the failure. The cost, who repaired it, how much time it taken, the effects from the failure. Even if this failure didn't happen before, as we said in the previous lecture, we could anticipate what's going to happen from the experience of the team we will select for making our decisions. By the way, there's one lecture should be coming before this, which is the one about the operations, but we are going to make it later because we need the information of to understand the value of the information of the production team. You need it with the decision worksheet, so it's better to describe or to explain this in the coming video after we have in hand the information worksheet and the decision worksheet. Now simply we are going to go through what we are going to make with the decision worksheet. The first thing is the reference. So the first part here you can see is the reference, which is F, FF, and FM, and this is coming in the form of numbers. So simply the functions, it's function number 1, function number 2, function number 3, or whatever I will serial them, but 1, 2, 3, and those are the main primary and secondary functions. Then for each function you will list down some function failures, which are complete failures or partial failures, and how they fail, which are the failure modes. The cause of this failure is the failure mode. So maybe 10 failure modes or whatever you like to make the number, just that's a sample. So for each, for example, we can have 1A1, 1A2, or 1P1, 1P2. Those are the numbering that it will be placed in the sheet on the top here. That will be placed in the top here, 1A1, 1A2, 1, and so on, 2A1 or 2, but PC, whatever. You are going to number your failures and so on. So the first one is a number, the second one is a letter, and the third one, which is the failure mode, is a number again, so we can understand the numbering in an easier way. So that's the first 3 columns. Then after that comes the H, S, E, O. So H and S usually comes to health and safety, but here H is hidden failure. A failure which is hidden, it is placed as the first failure to inspect if there's a hidden failure, because usually the hidden failure will result in other failures that may result in safety or health or environmental or operational costs. So that's why hidden failures are placed on the top, and you need to check them and to check the actions taken to prevent them if they are visible and so on in the first. So as we said, the H stands for the hidden failures, S stands for health and safety, E for the environmental, and O for the operational failures. Okay, and after we say no to everything, so there is N, which is non-operational consequences or non-operational, because now that HSEO is the consequences, so it's having hidden consequence because we don't know that it will fail or not. It's having safety consequence, health consequence, environmental consequence, operational consequence. If all of this is no, like example in 1P1, all of this is no, then it's an N. An N means that there's no operational consequences. It's having only the non-operational consequences that might be the cost and the man hours and so on to repair this failure which is having no operation. For example, a standby bump. If the main bump is failed, then we switch to the other standby bump, and now the main bump was the standby one from before, and the standby now is failure mode, in a failure mode. So that's a hidden failure. If we didn't take an action to repair this pump, it would be as a hidden failure to the main pump that it is working, because if it stopped, it will completely, the production will stop. So we need to understand these terms, what we mean by hidden. Hidden failure also comes from the protection relays, the protection valves, the release valves. They don't operate all the time, or any valves that do not operate all the time. They are stand open, and when the power fails, they should close, but they are stuck in the open mode. That's a hidden failure. If the standby pump is failed, if the protection relay that protects over current or earth or something like that is not working, or short circuit, that's a hidden failure which will have a consequence. That's the hidden failure consequences that we are speaking about. Safety, any safety conditions that you are placing or making some health problem to the employees. Either this health problem is on the long run affecting their health, or immediate one, an injury or something like that. That's for the S. For the E, for the environmental, which is breaching any environmental rules, either internal, external, national, whatever environmental rules you are following. And O stands for the operational consequences. So that's the negative effects on the operation, quantity, quality, cost, available time, whatever operation rate, whatever you consider as effect on the operation. Maybe it's because operation rate also is having an effect. If the rate operation or production is reduced, that's effect, because it will result in less production numbers, increased costs, more fuel used. Rework also will make more costs of refuel used, some raw material scrapped, and so on. So that's all these are operational consequences. So I hope we had some right. H, S, E, and O. If all of these are they do not exist, then it is non-operational, which is only the cost of the repair. The levels of the task, we have 3 levels of the task for each one of these. So for the H, which is hidden, we have H1, H2, H3 failures or levels of actions that we can take, and then we have S1, S2, S3, O1, and N1, N2, N3. So each level denotes an action that can be taken. So now when I say that H1, that now I'm looking for an on-condition task. So the priority is to find some on-condition task that can tell me that should be feasible. Feasible means that the cost of doing the task will be less than the cost of the failure. So now in our failure effect, SA-type failure effect, we had collected a lot of information, a lot of data. But now I need to compare the cost of doing this task, which will prevent this failure or reduce the rate of this failure. I need to compare this cost to the cost of the failure itself. So my action or my on-condition task, will it be matching less than the failure, or less than the cost of the failure, or it will be equal or higher than that's not the proper selection. Maybe there is some restoration task. Restoration is overhauling task. It means that I'm repairing the equipment in its position and returning it, greasing, adjusting stroke, adjusting whatever you are doing as a repair. So, and the third level will be the discard. This means I'm changing the limit switch completely, I'm changing the pump completely, changing the valve filter completely, whatever. That's a discard task. So I'm throwing a part away and to the garbage and placing another new part and so that's the 3 levels, 1, 2, 3 for the hidden failures, for the safety, health and safety, for the operational, and for the non. Of course, health also and safety, that's very important for us because it's health and safety and not them. So there are other tasks that are the default actions. So we had passed over all of this. Here, the safety and environment, they are treated on the same level. That's why we don't see E here at the H1. When we're seeing H1, S1, and so on, that's the 4 HSON on is no operational effect or consequence. We don't see E because E and S, they are treated as the same level. So safety and environmental, they are treated at the same level of the importance. So we start by H, then by S and E. That's S is for S and E, and then operational, and then non-operational is the last one. Then comes the default actions. What do we mean by the default action? Suppose that for any failure, for example, like this one, for example, which is 1P2, we have, there's no visible on conditions, there's no visible restoration, there's no visible discard tasks. Then I need to come to H4. It starts by the hidden failures because that's the most important one, okay, for the hidden failures. Okay, so for the hidden failures, if I didn't manage to reach to any of the levels before, we shall look for a failure finding. Okay, that's important. We shall look for a failure finding mechanism, like testing the oil, like testing the protection relays, like testing the valves. That's failure finding. So we need to stop and test the equipment. So if this is feasible in cost, then we are going to select the H4 level, which is making failure finding or testing for this equipment. Okay, for each of the operational and non-operational costs, if there's no feasible tasks at all the levels, then we stop and we move it to no scheduled maintenance decision. We move it to no scheduled maintenance decision. Okay, that's our choice is no scheduled maintenance decision. If there is no operational and there is no N4, there is no O4, it's all stopped at here. For the safety and the environmental, if the S1, S2, and S3, that's safety and environmental, it's checking both. If there is no, then the decision should be based on the importance. It should be evaluated from the company, and then we should look for a redesign of the equipment or combination of tasks that may result in something like this. So we should make some brainstorming, be creative, and find some combination of tasks that can prevent this failure, and it should be feasible. Or make a redesign. Redesign can be simple, as I told you. If you change the label, if you put some interlock or something like that, this can be considered as a redesign, which is efficient. Redesign does not mean that we need to change the equipment completely. For the H, which is a hidden failure, as I told you, we can go down to H4, which is the start looking for a failure finding condition. In case that there is no failure finding conditions, we go to H5, which H5 is equal to S4. It's treated like an S4. Then we need to go to look for some tasks that's a combination of different tasks, or to make a redesign. If this also is not visible for the hidden task, then we will transfer it to no scheduled maintenance, and we will let the equipment fail. So like this, we had explained all the levels. We had explained the sheet. We will check the operations effect or the operations feed that we need in all of this in the coming video. Then we will make some examples after that soon. Thank you for following so far. See you following the channel, following the other videos. Subscribe. You can ask for our services from our web store, or you can check for you will find the links in the description box, or you can join our trainings for maintenance or for digital skills. Even all of this is on Udemy, and it's usually on discount and reduced price, and you will find our coaching and consultancy services directly from our store. You'll find also the links in the description box, and in our post. See you in coming videos with more insights on reliability-centered maintenance.